Maps. Everyone knows how important they are. They help us get from point A to point B. Okay, most maps use or they make use of an index and a coordinate system and or coordinate grid system. So what I mean by index is usually on maps there's the bottom horizontal line, okay, that we can look for going east and west. And then there's vertical line that tells us, that shows north and south. Well, in the math world here, we have something that is called the coordinate system grid or the Cartesian plane. It was developed by French mathematician Rene Descartes. He was born in 1596 during the Renaissance era. Okay, now basically, the coordinate system is a computer that's based on input and output. Now, in math, we assign variables to represent the input and output. X is used to represent the input, and Y is used to represent the output. Okay, let me pause this video really quick, or I should say quickly. Okay, and there are a couple of things we should know about functions. Um, Functions, they have qualities to them. And one of those qualities is, or two of those qualities are even and odd. A function is even if you put the opposite of the input and you get the same output. So in other words, like instead of putting in a positive 2, you put in a negative 2. Let's just say you put in a positive 2 and you get a 4 for the output. Well, a function is even if the equation makes it to where if you put in the opposite of the regular x value or the regular 2, you get the same value. So here we go. Let's see if you can see this here. All right. So if you see here, let's see. Okay. So here we have make sure that's close enough. Here we have the function of x is equal to x squared. If I plug in a 2, function of 2 is equal to 2 times 2. 2 raised to the second power is 2 times 2, which equals 4. So the input is 2 and the output is 4. So we have an x coordinate of 2 and a y coordinate of y. So we want to know if something is if a relation is a function, or I'm sorry, if a function is even. Well, if you plug in the negative x and you get the same value as the positive x, then it is even. So for instance here, because like just say if I put in f of -2, I still get +4. This graph is considered even. So if it's even, that means it reflects about the y-axis. This is the x-axis and this is the y-axis. Now, as far as odd functions, okay, if you plug in the negative x and you get the opposite output. So if you get a negative x and you get the negative result, then the function is odd. So this is what it looks like mathematically. Here you have the function of x, or the function of negative x is equal to the negative value of the function of x. So the opposite x value of a relation yields to the opposite output of the relation, then it is a function. So here it is right here. Function of negative x equals the negative function of x. What do we mean by the negative function of x? That means just the opposite of the function of x. So for instance, here, if we plug in 2 into this this example, the function of x is equal to x raised to the third power, or x cubed. Okay, function of 2 equals 2 times 2, which is 4, times 2 is 8. So function of 2 is 8. Well, a function of -2 is a -8. You see how this 8 would be the positive output? Well, the opposite output would be a negative 8. So right here, the function of 2, we go out 2, we go up 8. Now the opposite of that is we put in a negative x. So function of negative 2, and the opposite of 8 is negative 8, so it goes down 8. And you see how it's reflected. If I were to take this quadrant and flip it up here, it would be the same. Let me pause this real quick because I want to have a good view so you can see it. Okay, here is a graph of y equals function of x is equal to x cubed. You can see where the 2's go to the 8, the 3's go to the 9s. I'm sorry, the 27 actually. 3 go to 27 because 3 times 3 is 9, and 9 times 3 is 27. So, okay, I'm going to pause it so we can go to the next step. And actually, that is all what we're going to go over for today. I just wanted to introduce even and odd functions so that way we can stop being afraid of those types of graphs. We're going and stop being afraid of how to solve them, how to manipulate them. First, we have to learn what they're about, and then we'll get into more practice with them later. So again, a function is even if you plug into the negative. If you plug in a negative x, and it is the same output. So if the function of negative x is equal to the function of x, in other words, you plug in positive input, you get positive output. If you plug in negative output, you still get positive output. And it would be the same thing if instead of the y going up, if the y was going down. Let's just say you put in a positive 2, and then it goes down 4, negative 4. Well, it's even if you go to the left 2 and you go down also the same direction, the same output, negative 4. That would be even. Output, odd functions, they basically flip twice from one quadrant to the next quadrant and the next. So that's what it means by flipping. It's even about the origin. And if you take a look at this drawing here, you can see it. If I were to flip this half, you see right there? If I were to flip this over here, then it would be right here. Okay. And then if I just take that and flip it over here, then there it would be right there. So that's what I mean by coming from one quadrant, flipping it once and flipping it twice. And then that would make it odd. So again, let's take a look. Here is the equation. The function of x is equal to, the function of negative x is equal to the negative function of x. That's odd. That's when you get, what we call it's symmetrical about the origin. Here, if you plug in a negative x, but you still get the same positive function, then that is considered even. Okay, we're going to rest here and take this in and process it. Thank you for watching my video, and I'll see you in lesson part 2 of the next video series. Thanks for watching.